Hai, Assalamualaikum warahmatullahi wabarakatuh to Nur Akila. My name is Nurdana Amira binti Muhyiddin. My last 4-digit registration number is 1045. My teammates are Muhammad Aiman bin Amir Rizal 1042, Muhammad Afi Aidil bin Azahari 1032, and last is Surya Tashini anak perempuan Marin 1039. Now we're gonna start our presentation about vector and scalar in plane. So first, introduction. A quantity which does not depend on direction is called a scalar quantity. Vector quantity have two characteristics, magnitude and direction. Scalar quantities have only a magnitude. The resultant motion of the plane is terms of displacement, velocity, and acceleration are also vector quantities.
So now, I will explain about the situation. An airplane take off from Johor to Kedah at an airspeed of 425 miles per hour around 4 p.m. The wind is blowing from the northeast at 40 miles per hour. Initially, the plane traveled due west and the wind is from northeast, so it is blowing to the southwest. The angle between the plane course and the wind is 45 degrees.
Now, I will explain the calculation to finding the resultant velocity, and also I will use a scalar and vector solution. An airplane flies due west at the speed of 435 miles per hour. The wind is blowing from the northeast at 40 miles per hour. What is the ground speed of the airplane? What is the bearing of the airplane? Now, we already know the situation and the problems here. Initially, the plane travels due west. The wind is from the northeast, so it is blowing to the southwest. The angle between the plane course and the wind is 45 degrees. Set up a sketch so that the internal points of the vectors lie at the origin. Then, the plane velocity vector is P equals to negative 435i. The vector describing the wind makes an angle of 235 degrees with the positive x, which is W equals to 400 cosine 235 degree, also 40 sine 235 degree. We calculate and we get the negative 40 per square root 2, also negative 40 per square root 2, and we get the last answer is negative 40 per square root 2i, also negative 40 per square root 2j. Next, when the SP and the wind add together on the plane, we can add their vectors to find the resultant force, which is P plus W equals negative 435i plus, in the parentheses, negative 40 per square root 2i, also negative 40 per square root 2j, and we get the answer is negative 435 minus 40 per square root 2i, also negative 40 per square root 2j. Then, the magnitude of the resultant vector show the effect of the wind on the ground speed of the airplane. To find the magnitude, we use a formula which is square root x power 2 plus y power 2. P plus W equals the square root negative 435 minus 40 per square root 2, the power of 2, plus negative 40 per square root 2, the power of 2, and we get the last answer is 454.17 miles per hour. As a result of the wind, the plane is traveling at approximately 454 miles per hour relative to the ground. To determine the bearing of the airplane, we want to find the direction of the vector P plus W, which is tangent beta equals to negative 40 per square root 2 per negative 435 minus 40 per square root 2, and we get the 0.06, and we use the tangent and we get a 3.57 degree. The overall direction of the plane is 3.57 degrees south of west.
In this case, we do scalar product and vector product as we choose the aviation topic. In this topic, we create a situation and a problem and try to solve it with using the formula. Moreover, we also have basic knowledge about this topic. From this, we can conclude that vectors used to represent the quantities of both, which is magnitude and the directions. We can add vectors by using the parallelogram method or a triangle method to find the sum. We can multiply a vector by scalar and change its length or give it to the opposite directions. Subtraction of vectors is defined in terms of adding to negative of the vectors. So that's all from us. Thank you for listening.